Okay. My name is Vidvuds Beldavs. Lived in the U.S. for most of my life, and I'm here from 2012. My talk will be about Moon Earth towards a space resources based economy. And here's what I'm going to be talking about. I'm a little bit of an outlier. My forecast is that we're in the beginnings of what I call the Great Transformation. In the period 2021 to 2050, what I would call a space industrial revolution. I will talk about drivers for lunar industrial development. Also talk about markets for lunar industrial development, markets in Earth orbits, cislunar space, lunar surface, the work of DARPA, known 4D, and touch on lunar resources and processing options, and work by NASA and others in that regard. And then I'll touch on ESA's forecast exercise 2030 to 2050, which on Monday, they just announced a new segment of that. It's about a €2 million foresight exercise. And then I'll talk about the Riga Photonics Centre WikiStrat foresight exercise, which at this point we're planning mid-June, but that's probably a little bit ambitious. And then I will end the talk with comments on a rules-based order for outer space development, because without a rules-based order, none of this will come to pass. So here's looking at the Great Transformation. At this point, the space economy is Earth-centric. Forecasts are that this space economy, presently 400 billion euros, approximately, could reach 1 trillion euros by 2030. And my forecast is that we're looking at with moon resources being exploited, that we're looking at a moon-Earth system with major industrial activity on the moon, supplying manufacturing, tourism, and other options in Earth orbit. The most significant factor here is the launch cost breakthrough. And Elon Musk aims launch to LEO at $10 per kilogram. Independent analysts that I've looked at, possibly $200 to $300 is plausible by 2030 and thinkable possibly by 2040 and beyond. And how low can launch costs go is a fairly in-depth article that it's a link in the presentation. At $100 per kilogram, a round-trip ticket to the Voyager hotel could be under $50,000, which would mean that many can afford $50,000, and very large-scale space tourism could get underway. What we're seeing, though, is low launch costs will radically increase opportunities in space. However, what we're also seeing is the launch of constellations of satellites in the thousands and thousands. We're also seeing an increase in the cadence of launches from multiple sources. And we have an increasing risk of having a Kessler tragedy in which the space is overcrowded with debris, which would put an end to spaceflight for quite a while. So that will be a factor to deal with in the coming decades. One factor in lunar industrial development is its low gravity. And this illustration is from Crawford's analysis of Lunar Resources, which is excellent. It basically shows the depth of the gravity well of the Earth, and that launch costs from the moon, we're looking at 1/20th of launch costs from the Earth, and that's just including the gravity, not including the atmosphere and other issues to overcome. However, the opportunity is further. To launch to the orbit of Phobos in Mars, the delta V from the lunar surface to the Phobos orbit is less than the delta V from the surface of Mars. So initial industrial activity in Mars orbit would benefit from lunar industrial development. You can't really bypass the moon and do sensible things on Mars. So the concept of lunar industrial development is low-cost launch from Earth, makes manufacturing, logistics, commercial research feasible in multiple areas thus far unforeseen. My claim is something that is controversial at this point, is that the moon can be the low-cost source of materials for structures in Earth orbits, cislunar space, lunar orbits, Mars orbits, and so forth. And again, it's the vacuum and the 1/6 G for extremely low launch costs, and also for ease of some manufacturing processes. Lunar Resources, and this has been the showstopper to date. Nobody has thus far discovered concentrations of palladium, metals, and other materials. There is some concentration of thorium, and there is a possibility of a massive asteroid under the Aitken Basin at the South Pole. This is an object that's estimated to be 110 kilometers in diameter, and there's a, many probably have seen, if you haven't, then you'll find it quickly. There's an asteroid called 16 Psyche, and that asteroid, you can find articles that say its value is multiple quadrillions of dollars because it's metallic. You know, you're looking at nickel, you're looking at precious metals and more. However, Psyche 16 or 16 Psyche is beyond the orbit of Mars, and it would be extremely costly to recover that. So the conventional view is the moon is similar to Earth in its composition. Very massive infrastructure would be required to process lunar materials, using conventional processes. There would be extremely high startup costs, no clean market, and no foreseeable business costs. The new options that are emerging is water on the moon, and the link in the presentation is to a project or study done with the University of Colorado, or Colorado Universities of Mines, and it looks at water recovery. And the claim there is that water delivered to low Earth orbit at $1,500 per kilogram could be profitable. But no one knows if that can be done. No one has gotten any instruments into the deep craters where the water is present. However, it is present. The other option that I've been involved with myself is structural materials from the moon. This includes basalt fiber, various other forms of sintered basalts, e-glass, which is a high-end material used in fiberglass. Those who have looked into basalt fiber can produce very light objects, and these can include massive, large-scale wind turbine blades. It can also include shields for spacecraft and for example, the nose cone of Soviet missiles, intercontinental missiles, was from basalt fibers. And the technology has proceeded. Basalt fiber can also be used for bulletproof shielding for helicopter fuel tanks. And also the Russians have proposed using basalt fiber shields against space debris, among other things. I put together a project in 2018 with the Aachen University, the Yuzhnoye Space Center in Ukraine, Riga Technical University, and us to process basalt fiber on the moon. The Aachen group had done earlier work on that. The Riga Technical University has an alternate approach because you have to overcome the problem on Earth. Basalt fibers are, you heat the material to 1500 C and draw fiber, but that's using gravity. On the moon, the attraction force is too low, so you need alternatives how you can draw fiber. The Aachen group is looking at drawing fiber, spinning fiber, and then using that in multiple processes. Another technology is plasma processing materials, and that's somewhat similar to the use of laser for spectroscopic analysis, but it's to actually process the material into its components. And then, of course, nuclear rockets could significantly reduce the cost of space transportation. This is an image of Peter Schubert's process for plasma processing of lunar materials. Peter participated in a workshop I organized about a month ago on lunar materials processing, and he has patents on this technology. And so his materials are available for those interested. I have discussed his ideas with people, including very well-known names, such as Eric Drexler, author of the book Engines of Creation, Nanotechnology. Eric was of the opinion that the process was too energy intensive, and he pointed to others. However, I think Peter has stuck with this for many years. I do think there's a possibility that it could work. And what you do with this technology is you feed 3D printers basically with feedstock of different elements. So your gold stream would go into a gold 3D printer and your other 3D printers. So, and he's proposing producing semiconductors, solar panels, and other technology with silicon on the moon. We're decades away from that, but I think 2050 is possible. So what the drivers are for lunar industrial development is the potential for major orbital infrastructure that can generate large returns, space hotels, resorts, settlements, hospitals, satellite assembly operations. Why should any satellite be assembled on Earth and launched in the fairing of a rocket and have to be subject to all those stresses? It makes no sense. Satellites of any size and complexity should be assembled in orbit safely and under much better circumstances. Also, water, fuel depots, and also space-based power. That is, all major countries have projects underway on space-based solar power, that is to deliver power to Earth gathered in Earth orbit. There's also pressure to build in space from lunar materials because of the overcrowding of launch that is very likely to emerge. We will have pressure to reduce the cadence of launches from Earth and look for alternatives. And again, the alternative is the moon. It's certainly not going to be Mars, and it's not going to be the asteroids in the asteroid belt. So we are then looking at, once you start building the infrastructure, things become cheaper and cheaper and driving down costs of the entire system. So the predictable trend is to lower cost sources on the moon in the longer term. This is an image of the Voyager Space Hotel. This was announced earlier this year, 440 suites. They claim a target of 2027 to have this operational. Most people do not view that as realistic, but the YouTube that's referenced there is pitched to investors, and it shows that this company, their strength is in manufacturing, assembly operations. That's a core piece of their expertise. They do have JPL experts and others on the team, and they have a stepping stone strategy to get to this idea. But I think it's highly plausible. But once you build one, you can build many because it is replicable, and the technology and the construction would be largely robotic. Where this can lead is to Jeff Bezos and earlier Gerard Conille's vision. What you see in the background image is what Gerard K. O'Neill and his team in the late 70s envisioned as space colonies built largely initially from lunar materials with forests even. This is a colony that probably would be 50 kilometers long. You even see fair-sized towns in there. And if you can create environments like this, then there would be people willing and able to take out mortgages to live on things like this. Okay. And particularly, where are we on time?
Yeah.
Particularly if we're looking at climate change, rising water levels in major cities where people already have apartments at 2 million plus, they could be attracted to living in something like this. Elon Musk, he claims he wants to retire on Mars. This is one vision. This is a SpaceX pitch or picture. The problem is the very great distance from the Earth. The 1/3 G is not necessarily good for humans. It may not be that bad. It does have an atmosphere, but the atmosphere is not suitable for humans. Terraforming, possibly after some hundreds of years. And Mars may have life. We have to be far more careful in doing things on Mars than on the moon. So I believe Mars at best within this century is likely to be on Antarctica, possibly with some research bases, but not with colonies as Musk envisions. But that's a part of the forecast. About 6 weeks ago, I participated in a workshop organized by DARPA, and this is to look at use of lunar resources to build large and also Earth resources. But the whole effort is to accelerate the rate at which large structures can be built in space at low cost, or at the lowest possible cost. And so they looked at the key problem they were looking at is materials, and then manufacturing producibility was extremely important. Peter Schubert put in a proposal to DARPA. I looked at that. International partners could participate, but I didn't find a way we could bid on that. But one of the things that DARPA is looking at, and this is for DOE and others, this is a dual use technology, is overcome the tyranny of launch. The tyranny of launch is that the spacefaring, when you have to create things that are extremely rugged and fit within the spacefaring, you limit what you can build in space. So this has overcome those limits So, you know, for DARPA, they're looking at extremely large antenna arrays, space-based solar energy projects, and so forth and so on. And there's some others, you know, we can go through that, but that's somewhat detailed. In that same pitch, there was presentations of what NASA's already doing in space manufacturing, and there's considerable work there with 3D printing and so forth. Time?
Yeah.
See, how many minutes?
Couple of minutes, no more.
Oh my gosh. Okay, we'll run through all this stuff. Artemis, and we can go through that. Moon to Mars, autonomous, and that's that. Here's very recent development. Number one was announced maybe 6 weeks ago, and I was approached by a company, OHB, and OHB was asking me for sources and materials on, you know, long-term developments in space. And I told them that's what exists, when it's been published, is going to give them false information because we're undergoing a major change. And what's needed is a foresight exercise, and I offered to organize a workshop. Well, they said, let's do the workshop later, and here's what's happened. That study is €1.5 million on the number one. Number two was announced this Monday, and so ESA awarded a contract to Euroconsult to take the stuff being generated by the three companies and to put that into into the context that will address the drivers for space transportation needs in the subsequent period. What I've done, and I did this when I learned of the OHB interest and ESA study, is I contacted a group that I've worked with for several years, WikiStrat, and they're a foresight in business. What they do is they look at new technologies, geopolitical developments, and other matters where there's high uncertainty, maybe many conflicting opinions, and they gather experts in those industries. One I participated in somewhat over a month ago was on mining in 2030. So they bought into the idea of doing a foresight exercise jointly with us, that we would organize a workshop for roughly 10 days that looked at the various facets of these issues relating to forecasting long-term developments in space. So, and here's their offer. The end is we need a rules-based order in outer space. Artemis is pushing one way, China, Russia another way. And right now, with no agreed to principles, there is no possibility. So here's the assumptions I would say are central to a moon-Earth economy. Thank you. So again, from the Riga Photonics Centre that engages in foresight activities, space policy, mentoring, and many other activities. Thank you.